Hello everybody, in today's video it's time to do some Grasshopper again. So I want to show you how to do this pattern inside Grasshopper, and yeah, that's basically it. There we are, Grasshopper, it's time again. Let's go to the basic viewport, perspective view, right? And let's open up Grasshopper. So I prepared the algorithms already, so all we need to do is basically walk through and I will explain what happened and why I did what. So you can follow along, right? So, I mean, you saw the pattern. It is this sort of pattern, like a soft wave pattern, if you will, at an angle. So the first thing that I want to do is basically create several lines and then divide those lines into sections and place points at each of these sections in order to create curves in between those points. So in order to do that, we construct a point at the origin. And then we construct another point somewhere else. Basically, this one is shifted by 73 in the y direction. And then we connect these points to create a line. So we have this line here now. Next thing I do is I move this line by 5 in the x direction and by 10 in the x direction. For that purpose, I just use the panel. And then make sure to go here and uncheck multiline data so that each line is read as an individual input, right? And then it also switches, maybe I can show that one. So usually if you do this 5 and 10, and then you go out, then this is read as a single input. You have to go here and uncheck multiline data for it to basically become a list. All right, so that's. Then I use the unit x vector, so the direction, and move the line that I already have by 5 and by 10, and then I get 2 more lines, right? So overall I have these 3 lines now in equal distance to each other, equal length, because they're just copies of the original line. The next thing I do is I divide these curves, all of them at once, into 15 segments each. And now we have points, right? And now I want to move the points in the center and then create new lines in order to loft the new curve that we create to give us the pattern that I was talking about, right? I use the panel to basically check how the data structure looks like inside, right? And now we have basically a list with 3 branches. Each of them has 15 items inside. So that's good. They're all the way they are supposed to, and they only differ basically in the x value, 0, 5, or 10. And now I use the explode tree to get like the individual branches, right? So the upper one is just all the points that are on the x point of 0. And the second branch, all the ones on 5 and so forth, right? So I can individually apply modifications to the branches rather than the whole point collection that I have. So I take the ones in the center because those are the ones that I want to move up now. And let's see, what do I do? Okay, that's already a second step. But basically is what I do. I move the points from the list. And now I'll add a slider. Right, now I can move the ones upwards. So if you look at all of them together, so you see that exactly where the middle ones were, I am able now to control their position in the z direction. So that's what I'm doing here as well. So let me remove that. Boom. That stuff again. But that's basically what I did here, right? So I take the middle points, but I dispatch them. Because the thing is that for our purpose of our pattern, we don't want to move all the points, because that would just give us a curved surface, but we want to have like every second middle center point to be higher than every other point, right? So we get this actual wave occurring. So what dispatch does is takes a list and basically divides it according to a pattern. So we have a list of points, right? Now it's 15 points, 16 points in total. And if I do dispatch now and place the same list in here, and then let's see, we look at the first 3, right? So now, based on the dispatch pattern, it will remove every second one. So that would be, no, it will remove every second one. Yeah, that would be 1, 3, and 5. So it will only keep 0, 2, and 4 in list A. Is that correct? Let's see again. So the first one is 0, 0, then 9.73, then 19.4. Yeah. Yes. So that's exactly what it is. And list B will keep all the others that were removed from list A in a separate list, right? So these are the points. And that's like the pattern. The dispatch pattern is true, false, true, false, true, false. So every second one. You can also, if you want to, create the panel and then write 0, which is true, 1, which is true, 0, which is false, 0, and then make this multiline data again and apply this as the dispatch pattern. And then we will see that we have more entries now in list B because we take the second and third entry and then we go put it into the list A again, and then the fifth and the sixth go in list B again, right? So that way we can control which items of our original list we want to separate into the two different lists, right? So that's what I did here with the very basic dispatch pattern. So every other one, and I move some of them in Z direction by 2.8 and some of them only by 1.6. Right, so that's what I'm basically doing here. So I take these points, I dispatch them in the list, and I move every other half that far and the rest not as high. And then I put them back together in the list. So where I use the weave command, so it takes the first of the first list and the first of the second list and puts them after each other instead of just creating two lists that are separate from each other or in two branches or whatever, right? So now I basically have back the original structure of my tree, which I can then use and merge it with my original branches and just ditch the other one, right? And now we have this point distribution. So that's basically exactly what I wanted. And this is what I did here. I moved these points also in Y direction. So we get this angle, right? If I go here, then we can see that it shifts. Because I also moved the third line actually in this direction, so we get this angle. And I moved it by 3. So for this part here, I just use 1.5 because it's half of it. So my angle is more or less correct. And then what we get is a list of points again, 3 branches, but in order for loft to work, we need like 3 points each in a branch. So for that to work, we use the flip matrix. So then it takes exactly the first entry of each branch and puts it in a separate branch and so forth. So that our output list looks like this, exactly like we want to. Right, so now we have, I don't know, 15, 16 lists with 3 entries each. And then I use the interpolate curve command to connect these points. And then you already get a glimpse at what the pattern might look like. And now, because it's parametric, we can still go in here and apply changes to, oh, that was not the X factor, but okay, to how high or low this looks. And also the second one, how extreme the effect is supposed to be, right? So we have total control over this kind of stuff. And then all that's left is do the loft. And for loft to work, you have to flatten these curves. So they're all in a single list. So they know which curves to connect with each other. And then you can also use loft options to basically apply some changes. So in this example, it's not a closed loft, right? So we don't have to, but you would put like a Boolean toggle. And you could do like true, and then it would try to connect the end to the front, but we don't need it, right? And then you can basically type as relevant. So we make a slider, and then we go and edit the slider to basically go to 5 max, because that's defined here. 0 is normal, 1 is loose, 2 is tight. So basically the same options that you have in the basic Rhino interface when you do a loft, right? But you have control over how this is supposed to look. So this is basic, soft or loose. Then we have tight, we have straight, and what's the 5th? Uniform. So I think for us, maybe this one works, or tight, whatever you feel like. and then you can just bake it and look at it in the rendered section. And that's basically the pattern that we have on the watch that I designed, right? But it's not close in shape at all, so you could now try to manipulate the shape so it actually goes into this ring shape, or you can do something else, which is what I did. And let's hide this for a second. Yes, and take your base geometry. So this is where I started with, right? I took this ring, and not even only this ring, but the surface of this part. So if I copy it, ungroup, and then Control Shift click onto the surface that I want to copy, and then Alt, and now I have it isolated, right? And now I import this surface to Grasshopper in order to basically build from that shape onwards. So here you already get to see some of the results, but let's not jump ahead too quick. So that was the basic simple approach that we are going to apply now, right? So here you see the surface that I imported. So that would be like tab one surface, right click, and then select the surface that you want to import. And I asked it to give me the edges, and the naked edges are the one at the top and the bottom, and the interior edge is the seam. And now let's see, what do we do? This one can go actually. Right, so here I take both the circles and I dispatch them, so I have access to both of these individually. I could also use other nodes, components to do that, but dispatch just works as well, right? And I take the interior curve and I divide it into 3 points or 2 segments, so I have the center. Also, there's many ways to get to the center of these lines, but that's basically what I did. Then I took only that middle one. I used the pull point to get a distance, and I moved one of the circles by that distance, so I get like another circles right at the center where I need it. So now I have these 3 curves again, right? Just like we did on the planar example. Then I use the area command to get the center of it, because I want to scale it, right? I want to become bigger. So I scale it from the center by this vector. So now I have these curves. You already see that, like, I go outwards, I get this curvature going. And now we can start to divide the curve. So again, what do we need to do? We want to get every other point and move it further out than the other points, right? So I'm here with all these points and I dispatch them again. So I have like every second point, and I scale the first half by this vector and weave them together back again with the other. So we get our original point list again. So that's exactly what we did for the other example. And then if you look what happens here at the top. So there we have these 2 base curves and are basically flip one of them because it had a different direction. That's not as relevant actually. I think I can maybe even skip it, merge them again, and then basically also divide these guys to get the same amount of points. That's also why I have exactly the same input here. So they're always the same amount of segments and points. I explode the tree again to be able to access these trees separately and entwine them to recreate my original data tree. So here is the middle one with the offset points, right? With the wave pattern. And then basically I take the first branch, then the weaved branch, and then my third thing. And now I have all the points that I need for this pattern to work. So if you look at the list, we have now 3 branches again with 52 points each, but we want 52 branches with 3 points each. So we flip matrix again, get the same result, can interpolate, and we see we get the curves. Some further out than others, every second one indeed. So again, we loft it, and we use the loft option to make sure that everything is going as we want to. So now I did the uniform type, for example, and it is a closed one indeed. but it's missing the twist, right? And also for this step, there's like so many different ways you can go about it. You can basically shift points, so the line doesn't go from this point to the one above, but to the one next to that one. And from that one, it doesn't go to the one above, but to the that one. That will also be a curved or not straight line, right? It will be diagonal across the surface. But what I do, because I already have set it up, I just twist it afterwards. I have the geometry of the loft and I just twist it. So I have to define a axis to twist around, and it also has to be in the exact height of my geometry, because I want to twist it equally and not just sections of it, right? You can, if you make the axis smaller, basically just cover half of it in the center, you will also only twist half of it in the center. So in order to get that axis, I go back here, I have these guys, I ask for their center points, and I sketch a line between those points, which is my axis now, in the exact same height, right? So I take my loft that I have here, and I ask it to be twisted along this axis. And here, usually it's in radians, right? So half times pi or 2 times pi or whatever, how many degrees. But I find it more intuitive or more controllable also with a slider if I just put like degrees in here. So go right click on angle and check mark the degrees. And then you can just use the slider to control the twist. So now, and maybe if you want to see it a little bit more clearly, I prepared a custom preview node, right? So there you can plug something in and it will show also in the color that you want it to show. And now you can really go to the max with turning and twisting. So now I twisted it like a lot, right? Also cool, looks very grippy. Maybe that's a little bit too much though. So, but you can play around with it. And then basically I just go here and bake it. No need to group it. And then I turn this one off again because I want to see my original one. So we're done in Grasshopper. Let's go here and I apply a material that I already predefined, which is this guy, right? And now it's still like an open geometry. So I just click it and do cap. And now it's closed, solid. Maybe you still want to fill it some edges. Let me see if that works. Reduce the size of the radius. Let's do 0.3 maybe. Chain edges. Does it work? Yeah, there we are. So I did that. I repeat the command, chain edges again. Do that also for the bottom. Right, there we are. So now if we look at it with everything included, then we see that it's a little bit too short, right? Because that's, I only took like a section of the thing, not the included with the fillet. So we have to rescale it a little bit, and you can just do that easily by pulling in this direction roughly. And now it's more or less complete. And that's all it took. And that's also the same way that I did these patterns. So this is just with a tight loft option, right? Which is tight. So I get these sharper creases. And this is with, I think, normal. What is it? So there's loose, there's tight. So that's the regular style. Yeah, just less extreme rotation here, less extreme twist. And that's basically it. The reason why I only took like part of the surface is because I felt like maybe I can, if I don't change the position of the rings at the top and the bottom, I can just merge it back again. But also then the tangency is a little bit off, which is why I decided afterwards to basically just recreate the geometry. It's very simple either way. And I still feel it's like a success. So if you look at it, I think this looks pretty cool. And now you can start and bring it into Keyshot or Viscom to render it, and you have your final result. All right, that was it. I hope you enjoyed this little Grasshopper excursion. If you have any questions, let me know. Otherwise, I hope you can use this pattern for your own projects. And yeah, no, I'm not the best in Grasshopper or anything, so there's always some problems that I also have to look up. So don't feel discouraged if something doesn't work, and just keep at it, stay locked in to figure it out. I think it's a great skill to have as an industrial designer to be able to visualize these patterns. Also, and model them, right? It's not so easy to do that in every software. So just keep going and you will get there. Thank you very much.